Swayam Prabha. Digital India. Educated India.
So welcome everyone, we are in the last lecture of module 7, that is lecture 5, and yes, it was mainly titled as damp proofing and insulation, and here I have included composites. And as you know, composites is a combination of two or more materials. So as you had seen, insulators, in the thermal insulators, those were not single items, but they were within a system. They were applied within a system, within a framing, and then it was covered with something. So that is why I thought of putting the composites in this particular section, and we will discuss what are composites. We have come across a number of composites by this time, but it is just to reiterate that what are composites. Its application in buildings, its application in structural systems, and again some nanomaterial applications which are also added to items to make it better working, better functional. So we will come to each of them. So coming to what are composites, composites are engineered combination of materials that result in a finished material with better overall properties. We had seen sand, we had seen cement, we have seen coarse aggregate, but when three of them in right proportions were mixed, we called that as man-made composite, that was concrete. So we had done that in one complete module. When we had done glass fiber reinforced gypsum, we have taken that as glass fibers inside gypsum laid so nicely that it gives strength, etc., etc. So it is getting better overall properties, and hence it is termed as composites. At a microscopic level, if you see, each constituents remain distinct. So there is no chemical reaction happening. There is no reaction happening where sand, cement, all these things bound together with water made the gel, and they could bind together all the materials, but the materials did not change property. So wood is a natural composite which grows naturally, where the cellulose fibers are there in the lignin matrix. So lignin is holding them together, the cellulose fibers together, to give it strength. And when we talk of engineered wood, there, yes, the natural wood is there, but these small pieces of wood are being, or strands or veneers in case of plywood, all are added using adhesive. So adhesive becomes the binder, and the fibers or the members or the pieces, those are the wood pieces. So that is the engineered wood is a composite made man-made, whereas wood is naturally occurring composite. So composites, if we see very precisely or deeply, we will see it has two phases. The first is the matrix phase, that is something which holds whom? The reinforcement or the particles that make it, that help the reinforcements to become more tough, more ductile. So they provide lateral support. So if there is a reinforcement, it will be supported at certain points by help of the matrix. Now matrix may be a continuous layer giving the support. It may be intermittent support. So actually the reinforcement may be covered on different sides with the matrix, with the binder. That is the matrix phase. So, these lateral supports to the fibers may be in the form of metals, may be in the form of ceramics, may be in the form of polymers, in any form. Next we have the reinforcing phase, that is, or the fibers or the particulate matters. In case of MDF boards, it was wood fibers, wood particles, wood particles. So, those are into the matrix. So, the reinforcing phase may be fibrous, may be particulate matter or particles, and they are strong, dense, light, but bound by the matrix to give them that continuity and give them to behave as one unit. So, need based alternative materials can be obtained by changing the percentages of the matrix or the reinforcement. You can get special characteristics, and what will happen? Finally, it becomes economical in the area where it is to be applied. Just giving the example, MDF boards may be of three types: light density, medium density, high density. So, by applying different amounts of pressure, giving different amounts of particles in it, you get three different kinds of wood composite. So, now you understand why I told initially that we have already learnt many of the composites. Now, coming to the applications of composites in building facades. As I told, you get special properties. So, composites usually have low thermal expansion and they do not corrode or rot, because we are taking that we are going to improve property. So, we can go for external applications using composites. We have seen precast slabs. We discussed at length in precast items, that particular module. Structurally integrated panels or SIPs, which are having foam or EPS or polyurethane sandwiched in between with a coating of maybe metal sheet or maybe oriented strand board or any other material which can withstand the external conditions. You get structural integrated panel. Now, what is the advantage of it? These are getting thermal insulation, at the same time lightweight. Where do we apply them? We can apply it where the structural system is there and you are using these SIPs as filler walls. Lightweight gives the other clue, makes the entire building load less. So, you can choose this for high rise buildings, tall structures. Coming to the next one, it is vacuum insulated panel. Here also the gas between the two members is evacuated out. When it is evacuated out, the inside becomes vacuum, hence it gives insulation, it becomes airtight. No air can enter, it is vacuum and it is light in weight and can act as a external facade. We have pultruded composite panel. This is also similar, where you are using resin coated glass fibers through a heat die. So, glass wool can be passed through resin. So, resin is the matrix and glass fiber is the reinforcement, and you can give any desired shape. You can get pipes, you can get walls, you can get, obviously you can make facades, you can make door window frames with glass fiber reinforcement within the resin. So, the major important point or the shift from the other two is it can take any shape, because the resin here is a thermoplast. Aluminium composite panels, we have discussed this when we did metals, non-ferrous metals. You can go back and see how it is made. It has a very thin core of polyurethane foam, and the facing and the backing, that is the two layers which is supporting the polyurethane foam, is aluminium. That is light weight, soft, you can bend it, give it any shape. The Epcot center was made of ACP panels. Many buildings, you see the building in the picture, you can see a circular kind of facade has been developed by using aluminium composite panel. So, we have gone through many of these materials earlier. Coming to other applications, as I told you, glass fibers as a reinforcement within plastic, pipes, sheets, corrugated sheets as you see in the picture. See the wood section here, the window section, frame which replaces wood, which replaces aluminium, which replaces steel, have now come into use. So, it has reduced the use of metals, it has brought in alternative material in use, and it is giving better result than the others. These are not getting corroded like iron, these are quite rigid, hard, durable. Pipes made with fiber reinforced plastic for high-rise buildings again, because the water is coming from say 200 meters. The pipe is facing that water regularly at a very high pressure. Its linings may get corroded, the internal walls may get corroded, but if it is made of fiber reinforced plastic, there is no corrosion. Elevator cables, they are made of fiber reinforced plastic. So, you can find out different applications within this building industry which have been gradually replaced by these composites. Here is again another picture of glass and aramid fibers together. So, here fiber is not one but two. So, this forms the matrix and it is in both the directions. So, when you put this within a matrix, then it becomes a very hard material, a durable material with very low conductivity, and they neither corrode nor get affected by any kind of environmental hazards. Even at times they are fire resistant. So, many good qualities can be achieved by using composites in place of our traditional or known building materials. We come to another important aspect of using composites, that is in the structural system. How can we get benefit from composites in structural system? Here you see some pictures where black denotes the iron part or the metal part and the grey color is the concrete. It is not like regular reinforcements. You see here there is an I section, two I sections together. Here you see one I section. Here you see it is entirely a solid bar. square bar. Here you see it is an entirely solid core of iron. Here you see within the I section there are again further reinforcement bars and it is filled with concrete. Same in the other pictures. These are examples of composite columns. Here you come and see composite beams. So you see this I section is a beam, is the major beam which is running horizontally, and onto which there are, you see there are rods, that is reinforcement, and there is a connector between the two. So the entire beam is not a simple concrete beam or neither a simple steel beam. Rather it is having reinforced beams as well as an I section beam, steel section. Here also you see the slab is on the top, that is projected on both the directions, but here is the I section which is behaving as a composite member. Coming to the picture below, here you see it is a slab which is cast within a member which is the steel deck. So the steel deck is nothing but a corrugated steel plate. Here you see the column is there which was repeated here. You can see this column here which has come here. So onto this is placed accordingly, this I section beam has been placed accordingly and the deck is resting on this I section beam. And what has been done? You cannot walk on such a floor. So it has been filled with concrete. So the entire inside is concrete as you see marked here. So you get a flat surface on top of which you can walk, but what is gained? You are not using reinforcement at intervals. Rather you have used a entire profile which is reduced the slab depth very drastically. So what have you gained? You have gained that loss of depth due to the entire thick slab. What more have you gained? You have embedded, you can embed these service lines, what you see in the red, shown in red or maybe black circles, where through which the wires, the conduits, the water supply, the air conditioning lines all can pass through, embedding them below the decked slab. What are you gaining again? You are gaining on height. So if you can save height in each floor, you will finally gain a floor maybe. When can that happen? When there are multiple floors, that is when it is high rise. Let us come to the major points. We can get larger spans using such kind of beam column system. So that means you will get uninterrupted space. We need uninterrupted space where? Say auditorium, say office, say multi-purpose spaces, sports arena, where we can go for longer spans. We need thinner slabs through use of steel decks. The deck itself provides a shuttering to the concrete which is being added on top of it to give it a smooth floor. Obviously, you get benefit on height and hence it becomes economical. Coming to the columns become much slender. That means you can avoid heavy columns that means dimension of say 1 meter by 1 meter reduces to say 500 cross 500. So that becomes the space saving. Your 1/4 of the space is required than a conventional column beam structure. You get more design opportunities because you are getting much of uninterrupted space, so you can play with space. Lesser weight because you are gaining, you are reducing height, you are using maybe some composite panels for the walls. So, finally, it is reducing the weight. You do not have to wait for 28 days because of curing etc., because it is already cast on a shuttering. So, further construction work can be carried on. So, you get speedier construction. Shuttering is not required, as I have already mentioned. Services can be accommodated below the steel deck, and mostly we find applications of these in high-rise buildings. So, I hope you could get through that the application of composites in structural systems, which you will see more in high-rise building application, tall building application, you will see these kind of composites being applied. But another group of composites are also there, or applications as a coating is there, which we also came across when we did glass. We had self-cleaning glass, which had a coating of titanium oxide, which helped it to clean or clear the glass time to time by the application of water or application of sunlight, and had kept the facade clean. That was a nano application. Nanomaterials can also go into composites. Carbon fibers can go into concrete to improve its characteristics. Silicon dioxide, nanosilica, improves durability of concrete. Copper nanotubes in steel helps to control the cracking. I am not going into details. Vanadium, molybdenum, they improve the strength of steel. They are only applied a very thin layer. Lignocellulose of wood, we had learnt lignin and cellulose. So, lignocellulose of wood is nanofiber of 1 to 100 nanometers used to reinforce concrete. So, you can understand that at nano level, that is 1 billionth of a meter, also these materials can improve properties. We had seen wired glass. Wire was embedded within glass to give it special characteristics. That is also a composite. These are also composites. See, application of carbon nanotubes and polypropylene gives fire resistance to concrete. So, there are so many benefits of building up composites, and yes, we are having a shift in building materials. Yes, we cannot do it in one day, it will take a longer time, but we need to open up towards these materials also. A lot of research is being done. You can use titanium oxide nano coating to get efficient solar collection, because titanium oxide is not allowing the dust to fall on it. So, obviously, your solar collectors is remaining better, cleaner. So, efficiency is going high of the photovoltaic cells. So, there can be very intelligent applications of these nanomaterials also in composites. So, with these I would like to end this module, and here are two other references from where I had taken these materials other than the books which I had referred earlier in my initial lectures. So, thank you.